Today we will have to move towards our last section of this topic of electricity section over there. We are moving towards applications of static electricity over there. Applications of static electricity. Static electricity. If we talk about it, we can simply say here that we are getting to move towards, first of all, I will say here, static electricity being helpful in inkjet printer, inkjet printer over there. What happens basically in the inkjet printer that the tiny droplets of ink are forced to come out from a fine nozzle, making them electrically charged due to, for example, I'm taking that jet of ink. This is jet of ink, which is having ink with a nozzle. And when they are forced to come through this nozzle due to friction, they are electrically charged. And there are two plates with the proper deflection plates are being shown over there. And in the front, there is a page present in front of it on which you will have to print in the form of color images to be highlighted with the help of image which is being given digitally through a computer to an inkjet printer over there. The droplets are deflected as they pass between two metal plates. For example, I say it is positive, it is negative over there. And these deflection plates are going to decide that it should go to which part of the page of the paper. And they are going to be printed over there. And the part of ink which is not being required on the paper over there is being deflected directly towards the storage bag named as gutter over there. It is coming back towards it. And we can say here a voltage is applied to the plates. One is negatively charged and other is positively charged over there. A voltage is provided to both of them in the form of positive terminal and negative terminal of the battery over there. And the droplets are attracted to the plate to the opposite charge and are repelled from the plate of same charge over there. Charge given to this ink over there, and the size and direction of voltage of each plate changes, so each droplet is deflected to hit the different places of the paper. So loads of tiny droplets make up your printout very cleverly over there. After that, the second one is photocopier machine. Photocopier machine. Photocopier is basically having the image of the plate, and it is consisting of an aluminum cylinder which is being coated with a layer of selenium. Originally, it is aluminum cylinder. It is coated with selenium. Selenium is basically a photoconductor. Photoconductor. When you observe for photocopy, there is a light from which is passing over the object page, which should be copied over there, and the writings make a shadow over there. And where the shadow is not formed, selenium becomes photoconductor and charge is removed from those points like that. Empty spaces, I have said that these are removed from these points, like empty circles I have left here, which are going to show that the light has not having any shadow at these points and charge is removed. Then you provide it with the help of a toner ink. Toner. For example, your aluminum cylinder is having positive charge, then toner will have negative charge and will be thrown over these positive points of the aluminum cylinder, and they got stuck. And then heated rollers are present over there. heated rollers are present over there, which are going to melt this dry powder toner into proper liquid, which should be getting to the point of view of printed form over there. And the paper is heated, so the powder sticks to it over there, and photocopy of your piece of paper is being obtained by using this photocopier machine. This phenomenon is being used by, we can say, static electricity over there. After that, static electricity being a little bit joker over there. For example, when synthetic clothes are dragged over each other, then we can say in a dryer machine over there, or ever on your hands, electrons get scraped off, leaving the static charge on both parts, and they leads to inevitable attraction over there, and they stick together, and little sparks and shocks as the charges rearrange themselves. So we can say synthetic clothes. Synthetic clothes are also available with the help of friction to slide over each other, and charges are rearranging themselves. Rearranging themselves over there. On the other end, when I go towards static electricity being a serious problem over there, then how can we state towards it? Then the best example is lightning of the clouds over there in the sky. We mostly observe that. For example, I say raindrops and ice bump together inside the storm clouds, knocking off the electrons and leaving the top of the cloud positively charged top of the cloud over there, and bottom of the cloud with negatively charged over there. Then this creates a huge voltage and a big spark is coming. And if directly it falls on any living object, then it can be dangerous over there. On the number 2 is fuel filling nightmare. Fuel filling nightmare over there I'm taking. Yeah, according to this application, we can say as the fuel flows out of filler pipe over there, for example, this fuel is coming out, then a static charge can build up at this point. Static charge is going to build up over here. Then what will happen? They can easily lead to a spark, and in dusty or fumy places over there, it will give a boom sound over there. And the solution make the nozzle out of metal so that the charge is conducted away instead of building up, and we should put nozzle away so that charge can flow away. It cannot build it up. It is also a good to have earthing straps between the fuel tank and the fuel pipe over there. So it should be, earthing should be provided towards the fuel tank over there, and also with the fuel pipe over there. These were little bit examples of static electricity. If I give you a little bit of a revision over there of this electricity whole section, then I will say here that we have checked about the current, that was the rate of flow of charges measured in amperes, and having a device ammeter connected in series. We are done with the voltage, that was work done per unit charge measured with the help of device voltmeter connected in parallel combinations over there. And there was also a term named as resistance, that we can say opposition offered by the conductor in the path flow of current measured in ohms. And ohm meter is a device that can also be used, but we use current voltage graphs and taking their gradient over there. And in standard test circuits, we also used ammeter in series and voltmeter in parallel across the resistor with the battery. And we used the difference of their measurements of our IV graphs values over there. We also checked about AC current and DC current over there. In AC current, we said they are going to change their direction at every moment. And in DC, we said they have only one direction and the current is directly provided to DC appliances over there. And then we also checked that there are graphs for constant temperature straight line, for a wire, for a resistor, for a filament lamp, and a diode over there. We observed about LED and presence of current for light LED. We have studied about light emitting diode over there. We also checked about the resistance of LDR, light dependent resistor, which is used mostly as a switch in the street lights also. And then we studied about series and parallel combinations of resistors over there. Parallel combinations of resistor. We also have studied about fuse, circuit breaker, circuit breaker. We also studied about live wire, neutral wire, and earth wire over there. And we also have studied about the parallel combination in all our house wiring and voltage staying the same, current is dividing. For series, we said voltage divides and current stays the same over there. We also have studied about electrical safety and energy in circuits over there. For that, we have used the formulas. And if I go for quick revision of formulas, I is equal to Q over T was one formula. V is equal to IR. And we also have taken for total resistance in series what R1 plus R2 plus R3 like that. And if we are going for parallel, 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And resistance of the wire, we said dependent upon directly towards the length of the wire and inversely proportional to cross-sectional area of the wire. We also said about power, P is equal to VI, voltage into current over there. We use the formula P is equal to V square over R. We also use formula P is equal to I square R. We used energy for electrical energy to calculate that VIT, voltage into current into time for which the current is flowing through that. We have studied about what is volt. When 1 joule work is done for 1 coulomb charge, we said then voltage will be 1 volt over there. And we also studied about circuit breaker that was RCCB, that was residual current circuit breaker, residual current circuit breaker. That was very efficient to use in our household wirings over there. RCCB over there. That was we have studied about. And we also have done that how fuse is going to work. Then we have studied about static electricity, in which we have studied about a gold leaf electroscope and also about insulators and conductors over there. This was our section 2, electricity for international GCSE physics. And in the next video, we will go towards our section 3 that will be related to waves over there. So kindly subscribe my channel and like the video, share the video. Thank you so much for today's class. Allah Hafiz.